Today we're starting with a very common food additive, MSG or monosodium glutamate. It's a flavor enhancer and we're going to see if we can use it for nefarious purposes and enhance the flavor of the chemistry in our lab. First thing we're going to do is convert this into the more useful glutamic acid. We're starting with 40 grams of crystalline monosodium glutamate as you can see here. First we've got this onto the stirrer and we're going to put a magnetic stir bar in. And now we're going to use 70 ml of water to get this into solution. Pretty soon it dissolves, forming a clear solution. Now we've measured out 18 ml of concentrated hydrochloric acid. This is 12.8 molar and so we've calculated this should be just enough to react completely forming glutamic acid. So let's add it to the MSG solution. Very rapidly the glutamic acid forms and precipitates out as a white solid. There's also a slight temperature increase. We've put the thermometer into the mixture so we can show you. Stopping stirring, the glutamic acid quickly falls to the bottom of the beaker. So we cover this up and chill it to ensure the maximum crystallization of product. And then filter. Take the time to wash with cold water and dry thoroughly. Okay, here's the product. We've got 36 grams here, which is greater than maximum yield, so it's obviously still slightly wet but likely to be a quantitative yield. It's a very fluffy white crystalline solid. Now we've got our glutamic acid. We can try a few different experiments with it. Firstly, we read about an interesting reaction which involves oxidizing this using hydrogen peroxide to obtain succinic acid. We've included the reference for this on the screen. We're going to start off with 25 grams of the glutamic acid that we just prepared. We've got this in a 250 ml beaker and we add a large magnetic stir bar. Now we add 60 ml of water to the beaker. Glutamic acid isn't very soluble, so this will create a suspension. Now we're going to convert the glutamic acid back to its soluble ammonium salt. You could use ammonia solution to do this, but we're going to use ammonium bicarbonate. This is available as baker's ammonia and is a useful source of ammonia in a dry and compact form. We've weighed out 13.4 grams, which should be about right to convert all the glutamic acid into ammonium glutamate. So let's add this carefully to the suspension. There's a reaction and carbon dioxide gas is given off. Don't add it fast as you don't want the mixture to bubble over. After a few minutes you can see a clear solution forming. So now we're ready for the hydrogen peroxide oxidation step. The procedure calls for 2.5% very dilute peroxide, but we've got 30%, so we're going to check this out. We've now switched on the hot plate and we're warming the mixture. We've got the thermometer in here as well so we can monitor the reaction temperature. Here's our hydrogen peroxide. We're using 58 grams of a 30% solution, which corresponds to a 3 times molar ratio of peroxide to glutamic acid. Just a word of warning. Make sure your glassware is really clean because 30% peroxide can decompose very violently and exothermically if it touches the wrong metallic oxide or some other compounds. Okay, here's our ammonium glutamate solution and it's now at around 65 degrees C. So time to add our first small portion of hydrogen peroxide. About 10 mils added, and the mixture starts to bubble. The temperature also starts to increase, and when it gets to about 80 degrees we use a cold water bath to keep this under control. And as you can see, there's a yellow coloration to the reaction mixture. Okay, temperature now is back down at about 65 degrees, so we'll add another portion of peroxide. As before, the reaction starts and there's bubbling and a temperature increase, but not as much as with the first portion. Over about 30 minutes we've added all of the hydrogen peroxide. And we're going to increase the heat slightly so that we get the mixture up to about 80 degrees C, and continue stirring for an hour and a half. During this time some ammonia gas is produced by the mixture, as you can see by the color change of the indicator paper. Over the next hour and a half stirring at 80 to 85 degrees C, the ammonia boils off and the liquid reduces slightly in volume. Okay, here we are, and the volume is now down to about 80 mils of liquid. There's still some effervescence, but there's no more ammonia coming off, and the aldehyde-like aroma that the mixture developed has also disappeared. We let the mixture cool right down. In theory this now contains succinic acid as well as probably a lot of byproducts. The original procedure says to distill the mixture to dryness, but we're not comfortable doing this with the excess peroxide present. So instead we're going to see if we can get some of the succinic acid to crystallize out. Here's 10 mils of 50% sulfuric acid. We add this to the cooled reaction mixture. There's no immediate precipitate, which means that there can't be much glutamate remaining in there. With chilling the mixture the cloudiness first appears, and this then slowly becomes a crystalline precipitate over the next 2 hours whilst chilling down. Let's filter. We dry as best we can. We've got 5.5 grams of a damp crystalline solid. It's really hard to dry, so we'll probably try to desiccate it and see if this works. Given the solubility of succinic acid in water, this is about what we expected to get, given that the remainder would stay in solution in the filtrate. The product is definitely acidic, and it's too soluble in water to be glutamic acid. If it's succinic acid then the yield is only about 25%, but there's probably more remaining in the filtrate. This can probably be boiled down and the further portion of product obtained. Well, this is interesting. The process is easy, and although it does use a lot of peroxide, the other starting materials are cheap and plentiful. We'll have to find a way to confirm that the product is indeed succinic acid, but if it is, then this represents the interesting way of preparing what is normally quite a difficult chemical to obtain. Thanks for watching and stay tuned.